Myself, Dr. Dipak Gapale, Assistant Professor, Department of Physics, Sangamner College, Sangamner. Now, in previous video, we discussed Cartesian coordinate system. So, in case of Cartesian coordinate system, we need 3 coordinates to represent the position of any object in a 3-dimensional case. So, these 3 coordinates are x, y, z. Now, here in this video we discuss spherical polar coordinate system. So, this is another coordinate system, and in that coordinate system, so if we want to represent the position of a point in a spherical polar coordinate system, so we need 3 coordinates, and these 3 coordinates are r, theta and phi coordinates. Now, then suppose this is a origin O, x axis, y axis and z axis. Now, here the coordinate r. So, the coordinate r, so it is the distance, coordinate r, it is the distance of point Q from origin O. So, it is the distance of point Q from origin O. Then the coordinates are having a dimension of length. So, it having a dimension, it represent the distance, or it, so that it having the dimension of length, and its range, if we see the range of this coordinate r, so it varies from 0 to infinity. So, the range of this coordinate r (0 to infinity), it varies from 0 to infinity. Now, another coordinate, that is coordinate theta. So, that theta it represent, so the coordinate theta is the angle. Okay, so this is the angle, that means angle made by this position vector r bar with the positive z axis. So, this is the positive z axis, and the angle made, so this is the angle theta. Theta is the angle made by this position vector with positive z axis. Now, in that case, if we see that the theta angle, so it varies. So, for along the z axis, so the angle is along z axis, this angle is 0, and it varies up to what, 180. It varies up to 180. So, in that direction, if we change direction, so in that case the angle made to the positive direction, so which is less than 180. So, if move throughout the circle, so its angle decreases, that means its maximum or it range of theta, so it is what, 0 to pi. Pi means 180 degree. Now, then third coordinate, that is phi coordinate, and this phi coordinate, so if we take the projection of this OQ on xy plane, so the position projection of this on xy plane, that represented as OP. OP is the projection, and this projection makes angle phi with the x axis. So, that means the coordinate phi is the angle between x axis and projection of OQ on xy plane. And now this angle, so this angle varies. So, along this x axis, so the angle is 0. So, if we rotate, so from the bottom, if we rotate, so suppose this is the x axis, and if we rotate this projection, so it moves from 0 to 360 degree, 0 to 360 degree, so that the range of this angle phi, so it varies from 0 to 2 pi, 0 to 2 pi, and 2 pi means what, 360 degree. Now, in this way we can see, that means the position of any point in spherical polar coordinate system is represented by 3 coordinates. So, these are the 3 coordinates, that is r, theta and phi coordinates. Now, then we can see that the position vector. Now, the position vector, that is OQ bar. So, OQ bar is the position vector, OQ bar. So, this is the position vector, we represent this as r bar. This position vector is represented as a r bar. Now, in that case, so here along this direction, the magnitude of this position vector, that is r. So its magnitude is r. Now the unit vector in the direction of coordinate r, or in the direction of r bar, position vector, so it is er cap, is represented as er cap, so that the position vector in spherical polar coordinate system is r bar, which is equal to r e r cap. While in case of Cartesian coordinate system, so we represent this position vector in the Cartesian coordinate system. Position vector is what? X I cap plus y j cap plus z k cap. So that means while representing the position vector in case of Cartesian coordinate system, we need 3 coordinates x, y, z, but in case of spherical polar coordinate system, while representing the position vector, so r bar is equal to r e r cap. So in this way we can represent the position vector. That means in that case we need only one coordinates to represent the position of a point, so that the position vector r bar, which is equal to r e r cap. Now then the coordinate surfaces and coordinate lines. Now first coordinate surface that we see. Now first, that means r is equal to, now along the coordinate surface one coordinate is fixed and remaining coordinates are varying. So if we take the coordinate r is fixed, so the coordinate r is fixed, that means the coordinate theta and phi is varying. So coordinate r fixed represent the surface of sphere. So it represent surface of sphere and whose center is at origin, and r is the radius of that sphere. R is radius and the center of that sphere is at origin. Now then the second surface, so assume second surface, that is the polar angle theta is equal to constant. So suppose this is the z axis and the angle made to this z axis, so this is angle 0, so here theta is some angle. Now for theta is constant, so it represent the surface of cone, okay, so whose vertex is at origin, surface of cone whose vertex at origin. So in diagram we can see these surfaces. Now here this is the conical surface, okay. Now this conical surface for theta is equal to constant, for r is equal to constant, so it is a spherical surface, and then for phi is equal to constant, so it is a plane surface, that means r q p o. So this is a plane surface, and in that plane surface whose one edge is along the z axis, so half plane surface whose one edge is along z axis. Now then the coordinate lines, so coordinate lines is the intersection of two coordinate surface, and along the coordinate lines one coordinate is varying and remaining two coordinates are fixed. So suppose first for r lines, line r, so now that means OQ is equal to r. Now along that lines coordinate r is varying and coordinate theta and phi is fixed. Then arc ZQZ, so it's on a sphere, and for that theta coordinate is varying, so theta varying from 0 to pi, and for that coordinate r and phi is constant. Then next circle, for coordinate phi is constant, so for that we can circle of radius OP and origin O. So for that phi coordinate is along that curve, the phi coordinate is varying and remaining two coordinates are fixed.